Okay, sorry about that, folks. Little continuation of the video. Ended up putting the wrong thing in my calculator. I went through part C and I wasn't getting the right answer. So I just erased that part and we'll pick up from there. Pretty generic, right? To actually use the trapezoidal rule here. Right? Like trapezoidal rule, I gotta actually remember that thing. You do, okay? 4 equal subdivisions to estimate the integral from 5 to 7 of s of t dt. And try to remember about trapezoidal rule, okay? Here you could use the expansion because it's 4 equal subdivisions. If it was, 4 subdivisions indicated by the data in the table or something like that, we have to get the area of each trapezoid separately and add them up. I'm sure you remember doing problems like that. More to come with that in review. But try to remember trapezoidal expansion always starts with a 1/2 times delta t, okay? B minus a over n, 7 minus 5 over 4 in this case, 4 trapezoids, which gives me 2 over 4, which is equal to 1/2, okay? So these two 1/2s mean something different. This one is from the formula for the area of a trapezoid. This one's the delta t. And remember, the trapezoidal expansion is going to start with f of the lower bound, or s of the lower bound in this case, and end with s of the upper bound. In between, we're just going to add delta t to the arguments, but we're going to put a 2 in front if it's not s of the lower bound or s of the upper bound. Speaking of s of the lower bound, that's s of 5 plus, if you add delta t to 5, that's going to be 5.5. That's not s of 7, okay, which is why we need a 2 in front, plus another 2. Now we know it's s of 6. Plus, the next one's going to be s of 6.5, so that's not s of 7 yet, so we need another 2 in front of it. And then finally, it's plus s of 7. Hopefully you remember how to do something like that, okay? If you don't right now, that's why we review, okay? It's something you could easily see on your AP exam. I'll show you have something with some kind of expansion approximating a definite integral. Once again, I'm not sure, okay, but it's very likely. This one's kind of annoying because you just got to put it in the calculator. Usually that doesn't happen. There's like a table when you could take the values and plug in here and then calculate. A lot of times you don't have a calculator. On your AP, I feel like you'll have to, but we'll see what happens. Look, it is annoying here. Okay, I have this thing in y1, remember? Okay, so y sub 1 of 5, that's s of 5, plus 2 s of 5.5, plus 2 s of 6. All right, plus 2s of 6.5, and then finally plus just s of 7. Make sure you put a double parenthesis right there. Shouldn't be too terrible to do this, but it's easy to make a silly mistake. That is the same answer I got when I did the problem earlier. So I get approximately 27.668. Had a dog named 27.66. I fed him 27.668. Yuck, yuck. Here, boy. Anyway, and I think they just want us to estimate it right there in part C. Part D is where things start getting interesting. They're saying using correct units, oh boy, explain the meaning of this integral in terms of cola consumption. And remember what S of t represents, the rate of consumption of cola, okay? The rate at which cola is consumed. And I gotta be honest with you folks, if you integrate the rate at which cola is consumed, you find out, probably only Samara is answering me, that's in period 2, the amount of cola that's consumed. That's what this 27.668 represents. Okay, that is the amount of cola consumed. Remember, integrate the rate, right? If you integrate the rate at which a quantity changes, you get the change in that quantity. We get the change in the amount of cola consumed. That means the amount of cola consumed. Okay, amount of cola consumed. Is it Pepsi? Is it Coke? I don't know. Maybe it's Dr. Pepper, or maybe it's Mr. Pips. I don't know if you ever heard about that. Mr. Pips is kind of like the bogus Dr. Pepper because the dude never even got his degree. Anyway, so the amount of cola consumed, now you have to put units here, okay, in, and the rate of cola consumption is billions of gallons per year. So the amount of cola consumed will be billions of gallons. So amount of cola consumed in billions of gallons in bilgal. But then you have to always, when you explain a definite integral, make sure you put a unit for the answer and you put a unit for the bounds from t equals 5 to t equals 7, and then 5 and 7 are in years. You could also say from 1985 to 1987 if you want to. You don't technically have to get that succinct with it, even though they'll say within the context of the problem, please explain. You could still use a generic explanation. Remember, if you integrate the rate at which a quantity changes, you always get the change in that quantity. If you do a definite integral, the answer is always going to represent some kind of change, okay? The difference of two things. The difference in the amount of cola consumed in 1987 between the amount of cola consumed in 1985. That's going to tell you how much cola was consumed from 1985 to 1987. And that bothers some people because if they go back to B, they're like, hey, wait, when we integrated the rate here, we got billions of gallons per year back. Yeah, the integral from 3 to 13 of S of t with respect to t represents billions of gallons, the amount of cola consumed. But then when you divide by 13 minus 3, that's in years. That's why it's billions of gallons per year. So the average value formula will always give you back the same unit as the thing you integrated because you end up dividing by time. Okay, over here, not the same thing, because you didn't divide by time. A lot of times in the AP exam, they'll give you an integral with a fraction in front. They'll ask you to explain it, and really it represents an average value. I don't think you'll see that in your AP. They said it's not going to be on there, but once again, more information forthcoming. So look, that was, it might bother you a little bit. Hopefully you get some points there. AP is all about accumulating points. That was really the first teeny piece of review. Let's jump back into slope fields and differential equations, for one last problem. And tomorrow we'll get started with the AP review. I don't know if I'm just going to have you, if there's going to be a video every day. I might just have you guys work on problems one day. Then the next day we go through a video going over problems. We'll see what happens. Okay, I'll figure it out next week. Anyway, consider this differential equation. I just considered it. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. When you take the AP, there'd be an answer booklet for you to put it in. Not this year. I guess you could be doing it online. We'll see how that works. Remember, to sketch a slope field, you just need to know about slopes. So you could draw little pieces of tangent lines. And here we have the formula that gives you slope dependent upon x and y. Okay, so you need them both. But you could simplify things a little bit. Like for all these 4 points right here, x is equal to 0. And if x is equal to 0, negative 2 times 0 divided by anything is going to give you 0. So a slope of 0. I said divided by anything. Remember, 0 divided by 0 is indeterminate. They don't ask you to figure out the slope at x equals 0, y equals 0. It's actually indeterminate right there, an indeterminate slope. That's why. Here, all these points have an x coordinate of 1. If x is 1, negative 2 times 1 is going to be negative 2. You just got to worry about negative 2 over whatever the heck y is equal to. Negative 2 divided by 2 is negative 1. Negative 2 divided by 1 is negative 2. Negative 2 divided by negative 1 is going to be positive 2. And negative 2 divided by negative 2 is going to be positive 1. So it looks something like that. On the other side of things, x is equal to negative 1. So negative 2 times negative 1 is 2. So it's really 2 over whatever the heck y is equal to. This would be the opposite of all these. 2 divided by 2 is 1, positive 1. 2 divided by 1 is positive 2. Okay, 2 divided by negative 1 is negative 2. And 2 divided by negative 2 going to be negative 1. So that's what it looks like. Maybe they give you the initial condition of the point, like, 1 comma 1. They want you to draw a particular solution. Probably look a little something like that, okay? 1 comma 1 right here. So it actually probably jump all the way down there. Kind of looks like ellipses right here. They don't ask you in this particular problem. Sometimes they do. Part B is really cool. This is going to be on your take-home that you'll get at some point this week. We'll figure it out. That other take-homes really due today, right? The day this video is posted. Part B. Sorry about this weird, problem with the printer right here. Blame John Glenn. I'm not going to blame the dude. He went into space, and right now he's resting comfortably under the ground, hopefully. Anyway, let y equal f of x be the particular solution to the differential equation. With the initial condition, f of 1 is negative 1, so 1 comma negative 1. Write an equation for the line tangent to the graph of f at 1 comma negative 1 and use it to approximate f of 1.1. We've done this, right? Local linearity. Don't give me no disparity. Okay, you could use a tangent line to approximate an actual function. That's local linearity. Some people are like, wait, what's going on here? Slow it down. Here they just want you to write an equation for the line tangent to the graph of f. F is the original at 1 comma negative 1. Equation of the tangent line. First thing we need is the slope of the tangent line. Slope of the tangent line. That means take the derivative. But I already have the derivative, okay? You just want to evaluate it. dy over dx. Evaluate it at the point, what? 1 comma negative 1. They even tell you twice for crying out math, in 2 different forms right here. And we already know that slope at 1 comma negative 1. That was the slope of positive 2. And that's the slope y'all are looking for. Okay, so a little something to think about right there. That shouldn't be too much of an issue. Now, second, we got what b is equal to. And that's when we plug in a y equals mx plus b. Replace everything but the b. Ow, stung me. Sorry, mx plus b. We know x is 1. We know m is 2. We know y is -1. They gave it to you here, folks, okay? So they really set you up. -1 equals 2 plus b. Subtract 2 from both sides, -3 equal to b. Therefore, even though there are 3 dots, we know the equation line tangent, y equals 2x minus 3. It's actually an incredibly easy tangent line problem right there. But, you know, things are a little bit different, okay? But we've been doing those since last year. Here, they gave you the derivative, they gave you the point. Easy peasy, lemon squeezy. But now we have to use it to approximate f of 1.1. I can't do f of 1.1. I have no idea what f is. We're actually going to get it in part C. Some people are like, well, we better get what f is equal to. No, all right? Why would we do that when they're actually asking us to get f in part C? We want to approximate f. And if you want to approximate a function and a nasty x value, even though 1.1 isn't really too nasty, construct a tangent line at a friendly x value close by, and then plug the nasty x value into the tangent line. So f of 1.1 is approximately 2 times 1.1 minus 3. So is that 2.2 minus 3, which is -0.8? I had a dog named Negative Point. I fed him -0.8. Here, boy. Anyway, not really a bad problem. Hopefully you guys were okay with that. You can always pause and slow things down. When you hit play, we'll be right back here. You know, let's take a look at part C. Now they actually want you to find the particular solution to that given differential equation with the initial condition of 1 comma -1 like before. Okay, so remember, dy over dx, I'll write it down again here, is equal to, I'll put the negative up top, which is always a smart thing to do. Let's separate and integrate. Cross multiply y dy equal to -2x dx. We're already separated. You got to keep them separated. If you know that song. You know, now we can integrate. All right, the integral of y to the first we know is y squared over 2. We put the plus c on the right-hand side. Pull the -2 to the side, integrate x to the first. Okay, and here you can see that we're going to end up with y squared over 2 equal to -x squared plus c. It's a perfectly workable general solution right there. But remember, I always keep the left-hand side as clean as possible. Clean it up of constants. I'll multiply by 2 on both sides. And that'll give me y squared equal to -2x squared plus c, right? 2 times a constant, just another constant. Some people are like, let's keep going. Let's solve for y. That would indicate I need to take the square root of both sides. That's an advanced algebraic technique. And I don't solve for y until I solve for c. So let's use that initial condition of 1 comma -1 or 1 comma -fun, which is what you're having. So -1 quantity squared equal to -2 times 1 squared plus c. So 1 is equal to -2 plus c. Add 2 to both sides. I get that c is equal to 3. And make sure you use, okay, that value of c in the general solution used to generate that value of c. So here, kind of doing a little something like this, okay, you know, and we know that now we have y squared equals -2x squared plus 3. And now it's easier to solve for y. And this is kind of cool because when you do solve for y, you want to square root both sides. And this answer right here is actually incorrect. Okay, remember, when you square root both sides, when you voluntarily take a square root, you need to indicate whether it's a positive square root or a negative square root. And it's not going to be both. You know, you want a particular solution such that when you plug in 1 for x, you get -1 back for y. Right now, if you plug in 1 for x, 1 squared is 1. -2 times 1 is -2. -2 plus 3 is 1. The square root of 1, if there's no negative in front, is +1. I don't want +1. I want -1. And that's why that negative is there, because y is negative. With the point 1 comma -1, you can see that y is negative. You know, you need to worry about that when you ln, right? Because you get the absolute value. You need to worry about whether you need to negate what's in there and not negate what's in there. I think that showed up on a homework, and it will show up sometime during the AP review. If you're worried about it, remember, when you plug in that initial condition, you gotta have it satisfy the equation, okay? So I know this has to be a negative square root, because if it was a positive square root, then it'd be 1 comma 1. So be careful with stuff like that. If it's a part 2, you flub that up, you're really just talking about losing a point. It's not the biggest deal in the world. But if it's a part 1, obviously you'd lose all the points. I think you're gonna have part 1s on your AP anyway. That concludes the curriculum for this course. I know you're cheering and are very happy about that. tomorrow we're going to start with the AP review. So I don't know if I'm just going to give you problems to work on. Then we'll do like every other day a video, or maybe we'll do every day a video. I didn't know what we're going to do yet. Okay, I'm still thinking about that. So we'll see what we see. Make sure you text that take-home assignment to me on Remind. There's going to be another take-home assignment this week for slope fields. And then you are going to have a take-home test, maybe posted on Friday. Have it due on Monday or post it early or something like that. I still don't have everybody signed up for Remind, so I want to kind of get that going before I start posting too much stuff. Anyway, get in touch with me if you need to. Text or Remind or email me, and I hope everybody's safe and healthy. And this is Berto signing out. We'll see you next time. Adios.